Okay, let us discuss problem number 2.36. So what this problem says, a piston can freely move inside a horizontal cylinder closed from both ends. So we have a horizontal cylinder here. So let me make the diagram. And this horizontal cylinder is closed at both ends, and there is a piston. So this is the piston. So let me make slightly something like this. So this is the piston. It says freely it can move. So piston can freely move. So free movement. So piston can move freely. That means there is no friction force. Initially, the piston separates the inside space of the cylinder into two equal parts of volume V0. So this side, these are equal parts. Volume is V0. This side also volume is V0. In which an ideal gas is contained under the same pressure P0. This side pressure is P0. This side also pressure P0 and ideal gas. So gases are ideal in nature. So you have gas is basically ideal. Are you getting? Now next part says, what work has to be performed in order to increase the isothermally. So I need to move the system isothermal. So the process is isothermal. Are you getting? So question says, what work has to be performed in order to increase isothermally the volume of one part of the gas eta times compared to that of the other part, slowly moving the piston, by slowly moving the piston. So this is the initial situation. Now if I move slowly, so let us say some forces is acting here, and this force can basically slowly move this piston. So finally situation is given. So finally system is somewhere here, and this movement is slow. So movement is slow. So slowly movement. Now there is a force F. Now see, question says the volume of one part is eta times volume of the other part. So let us say volume of this is V1. So the volume of this side will be eta times V0. So let me write. The volume of one part of gas is eta times compared to that of the other part. So let us say this side volume is V1. So then in that case the volume of this side is eta V1. So I will have the total volume will remain same. So first I will find what is the value of V1. So eta times V1 plus V1, and that the initial volume was 2V0. You see here, so this is V0 plus V0. So from here I can find the value of V1, that is 2V0 divided by eta plus 1. So this is the value of V1. Are you getting or not? If you want, you can also find what is this distance. So let us say piston area is A. So area of piston is A. Area of piston that is given. Let us say this is A. So I need what is the distance travel in this case. So this volume is I will need, so I can say this volume was initially V0. So this volume, the extra volume we have, the extra volume will be, so I am interested in this volume. So this volume is eta V1 minus V0. Are you getting? So this is the extra volume. Extra volume will be eta V1 minus V0. What is the value of V1? So V1 is 2V0 divided by eta plus 1, and this minus V0, this is the extra volume. So I can take 2 eta V0 minus eta V0 plus V0. I'm getting, so I have to multiply by eta plus 1 and then I will have eta plus 1. So this comes out to be eta V naught minus B naught divided by eta plus 1. So we will have eta minus 1 divided by eta plus 1 into V naught. Are you getting? So this is the value of extra volume. So this is the, I have to increase this volume. What is the extra length that I have to increase? So if I divide by area, so extra length, you say, extra length that I have to expand, that is volume divided by area. So this is the volume, eta minus 1 divided by eta plus 1, this is the volume divided by area. So this is the extra length I have to basically increase. Why I am finding this extra length, you will soon understand. Let us say, consider the equilibrium of the piston. At any point of time, this piston has reached, so initial situation was here when they were at equilibrium. They have gone at a distance x. Are you getting? So if they have gone into distance x, this side initial pressure was P1, so let us say this side pressure will reduce, now P0, now it will become P1, and this side let us say pressure is P2, and there is a force that is also acting this side, that is F. Now what is the value of P1? So value of P1 will be, because these are the pistons are freely moving and the system is the process is isothermal, so I can say PV is equals to nRT. Number of mole this side remains constant because no gas is going this side, no gas is going this side. So number of mole remains constant and the system is isothermal. So the temperature remains constant, so I can say P1 B1 is equals to P2 B2. So initial pressure is P0, initial volume is V0, now pressure is P1 and volume is V0 plus AX. You see, the volume is, initial volume is V0, now area is A, it has gone this side, so V0 plus AX is the final. So what is the volume of this? This is V0 plus AX. So from here I can calculate P1. This will be P0 V0 divided by V0 plus AX. You can also calculate P2. So let us calculate P2 in the same way. Now again I can write P0 V0 is equals to P2 V2. So this is P2 and V2 will be V0 minus AX, because this the total volume is V0 and this the volume is AX. So V0 minus AX. So from here you can write P2, this is P0 V0 divided by V0 minus AX. Now if you see, this system is moving slowly, so this means acceleration of the piston is 0. So acceleration of piston is 0. Are you getting? So acceleration of piston is 0. So this means total force on piston is 0. Total force, sum of the total forces on the piston is 0. So now what are the forces that is acting? I can say F plus P1 into area. So you see, from this side you have, in this direction you have F plus P1 into area minus P2 into area. Minus P2 into area. This is equals to 0. So from here I can say PF is equals to P2 minus P1 into area. Now P2 and P1, I have expression for P2 and P1. You see here. So P2 is P0 B0 by B0 minus AX. P0 V0 divided by V0 minus AX. And I have also expression for P1. This is, you see your copy. So this is P0 V0 by V0 plus AX. So P0 V0 divided by V0 plus AX. And I have to multiply by A. So this is the force. Now let us take V0 plus AX and common. So we will have P0 V0. V0 plus AX will be here and V0 minus AX and minus, so it will be 2AX. I think you are able to understand. Now this will be in the denominator, we will have V0 square minus A square X square. So this is the force. Now we have to find what is the work done. Are you getting? So how will we find work done? Can anybody give me some idea? So work done is very easy. I have to find f dot dx. This will be the dw. F I know. So now expression for f is p naught v naught 2ax divided by v naught square minus a square x square. This is f into dx. This is the work done. Now volume, initial volume was x. So let us say initial x, it is 0. And now in the equilibrium time we have already calculated this will go up to a height. So extra length is given by this volume, eta minus 1 by eta plus 1. So this is the x. So extra length, that is the x, final x. Are you getting? So eta minus 1 by eta plus 1 b naught by a. So the final limit will be this value eta minus 1. So that means I will plug the upper limit in the next line. So let us keep this limit as let us call this limit as x naught. So this limit is x naught. So let us plug here x naught. I will see in the next line. So let us do integration. So we will have p naught v naught. A is common. We will have 2x divided by v naught square minus a square x square dx. Now what I will do is, let us plug this as a z. First let us do integration. So v naught square minus a square x square is equals to z. So what I will have, differentiation of this is 0 minus x square is 2x, so 2a square x dx is equals to dz. So you see, you have already have 2x dx. So I can write 2x dx is equals to minus dz divided by a square. Are you getting? If I plug here, but I will have p naught v naught a now a divided by 2x. This value is v naught square minus a square is z. So this is z, and 2x dx is minus dz by a square. So this is minus dz by a square. So it will be coming out to be, I think you are able to understand. So p naught v naught by a square goes out with a minus sign, and dz by z is ln z. Are you getting? Now I think you are able to understand. Now let us go back to our original. So if we go back to our original equation, so let us plug the value of z. So work done will be minus p naught v naught by a ln. What is the value of z? Z is nothing but under root v naught square minus a square x square. So v naught square minus a square x square. Are you getting? Basically there is a mistake in the a. You see here, let us go to the back. You see here you will have, there is a, you will have 2ax from here and multiplied by a, so you will have a square. Check your copy. So you will have 2a square here, a square will be here. So this a square and this a square, finally there will be a square, and this is also a square. So a square basically cancel out, so you will have no a here. P naught v naught by ln z simply will have, so there will be no a here. Are you getting or not? So you will have simply this p naught v naught, so minus p naught v naught ln under root v naught square minus a square x square, and the limit is 0 to x naught, and the value of x naught is eta minus 1 divided by eta plus 1 into v naught by a. So this is the value of x naught. Now plug the value of this, you will have minus p naught v naught. When you have this upper limit, you will have ln v naught square minus x is this, so a square goes out, so a square, so you will have eta minus 1 divided by eta plus 1 whole square v naught square when you have the upper limit, minus when you have 0, so this is simply ln under root v naught square. So at the lower limit you will have this value. So this is minus p naught v naught ln. So this becomes, you see simply, so I can take V naught common, and this is eta plus 1 whole square minus eta minus 1 whole square. So let us say we will have eta plus 1 whole square minus eta minus 1 whole square. So you will have simply 4 eta. Are you getting or not? Divided by eta plus 1 whole square. So I can write this is eta plus 1 whole square minus ln V naught. So we will have simply minus P naught V naught, and this ln if divided by, so we will have this is ln under root 4 eta divided by eta plus 1. Are you getting? Or if you want to, you can absorb the value of minus sign, so P naught V naught ln eta plus 1 are divided by under root 4 eta. Under root 4 eta. Oh, so basically Z is not root. So you see here, I have done mistake. Z is simply V naught square minus A square x square. So this is the value of Z. So there is no root here. So V naught square minus A square, there is no root. So this is simply V naught square minus A square x square. No root here. So here also we will have no root. Are you getting? Here also we will have no root. And here also we will have no root. So simply V naught square. So this will be no root. So we will have 4 eta plus eta plus 1 whole square. V naught square will be here. V naught square will be here. And V naught square finally get cancels out. So we will have 4 eta divided by eta plus 1 whole square. Because there is no root. Eta plus 1 whole square divided by 4 eta. So the final answer will be P naught B naught ln eta plus 1 whole square divided by 4 eta. So this is the amount of work that has to be performed. So work performed by external agent, work performed on gas. So if this work is performed by external agent, this means this work has been performed on gas. So the work done is, you see, I can write in a vector B ln eta plus 1 whole square divided by 4 eta. So this is a quite interesting problem. Only thing is, you have to find pressure difference P2 minus P1 as a function of x. And once you know P2 minus P1 as a function of x, work done can be found simply by integrating. Other important point we have in this problem is, this piston has been moved slowly, that is the acceleration of system is 0, so I can assume that is the total force acting on the piston is 0. From there I can find the F, capital F, and then I can solve. Another important point we have, from initial condition, that is the volume of one part is equals to eta times volume of other part, from there I can find what is the total movement of the piston, that is x naught. What is the movement of piston? X naught. What is the movement of the total movement of piston? So I think all of you are understand. And there I have done one mistake that I have already explained. So Z is V naught square minus A square x square. There is no root. Initially I have written a root. Basically that is wrong. So simply V naught square minus A square x square. There is no root. Now here also you will have no root. I have to integrate x 0 to eta minus 1 by eta plus 1 B naught by A. If you plug this value, so A square will cancel out. So you will have eta minus 1 by eta plus 1 whole square B naught square. Now if you do this one, B naught square is common. Eta plus 1 whole square minus eta minus 1 whole square, that will come 4 eta. You can do yourself. Divided by eta plus 1 whole square. There will be no root. So here you have no root. Minus ln B naught square, no root. Now V naught square goes out because ln A minus B, ln A by B. And this is 4 eta divided by eta plus 1 whole square. So you see the total work done in this case is this. We'll discuss the next problem. Quite interesting problem this is.